Hi folks, this is part 3 of the Level Up DeFi lending series. In part 1, we created a contract that allowed us to deposit and withdraw and take a loan and repay the loan of Ether using message.value. In the second one, we switched over to ERC20 tokens. Again, deposit and withdraw, take a loan and repay it. Those two were kind of straightforward enough to implement if you had a little bit of experience in studying Solidity. And it's taken a step up today. So with those two, we're just getting used to kind of building out functions that accepted Ether, sent Ether out, or accepted ERC20 tokens and sent them out. Today, it's taken a jump up in that we're looking at the collateralized lending contract. And what this means is that we're going to have, if I scroll down here, the essence of the collateralized lending contract, we're going to have accepting collateral, tracking loan to value ratios, and handling liquidations. So we're going to need, essentially, loan to value is going to give us a health factor for our borrowers, and then if their health factor is above 1, their loan is healthy, but if it drops below 1, then they will be available to be liquidated. And what that means is that an external party can repay your loan and claim some of your Ether alongside a bonus collateral from that Ether of like 10% or something like that. So I'm going to switch over to VS Code. Okay, so unlike our previous two videos where I wrote out the contract while I was doing the video, I'm not going to do it with this one. So I've already written out the contract and I'm going to go over what I've done and why I've done it and where I stumbled and so on and so forth. The reason being that if I was to just write the contract out, you'd see me making mistakes everywhere and the video would be about 4 hours long. So we'll try and trim it down by going over a contract that I know now that I have implemented and that it's working. Again, it's probably sloppy in places. It's not gas optimized. There's probably, a lot of the functions are reentrant and stuff like that. But it does work, and that's the main thing about this contract. So I'm going to just go over what I've done now. So what I've done here is I've taken the contract from yesterday that had deposit, withdraw, borrow, and repay functions in it, and we were using the ERC20 tokens for that. So I've done just basically extending that contract and adding on stuff like health factor and liquidations. At the top of the contract, just to show you, I am importing ERC20 again, same as yesterday. I have this here because I was using it, using console 2 to debug. So when you do that, you can actually, just like JavaScript, you can do console.log or console2.log, I think it might be, and then you can write in stuff like you could console log amount, and it would say the amount here in your Anvil chain. Again, same as yesterday, the token is just going to be a basic token that we're going to use to put into the contract. The EMV file I'm going to go over. We're going to use a couple of the private keys from Anvil. I'm calling them Bob and Alice, so that they stand out when we're going over the commands later on. And they will be the same in your Anvil as well. Your private key will be I think it's the first private key, and the address be the first one. And again, just put your if you're doing this, put your lending, once you deploy your token, I should say, put the address in here, and once you deploy your lending contract, put the address in here. And then I have a make file here, which will just make it easier to see what we're doing later on when we have deployed the contracts and we're interacting with them. So just to briefly show you, the make file is shortcuts. So if we can just go make deploy token, and it will run this command, and make deploy lending, and so on and so forth. So we're going to deploy the contracts, then we're going to approve deposit withdrawal tokens, then we're going to borrow tokens with collateral with ETH using message.value, and then we're going to repay the tokens and get ETH collateral back. And then at the end, we're going to try and perform a liquidation. And down here we have liquidate borrower, which won't work because they are actually over collateralized when they're taking the loan out. But then we have this nuke health factor, which will essentially drop the health factor so that they're then liquidatable. So I'm going to switch back over now and just go over the contract. Okay, so here's a token lending contract and our state variables balances. Again, this is the same as yesterday, ERC20 token. It's just called token. We have 3 mappings here. This is called token collateral balances. Shouldn't be called collateral, should be just called token balances. I'm not going to change it now because the tokens that are put in using this deposit aren't actually collateral. They're just the tokens that people can borrow. So the 2 first functions in it, Deposit and withdraw I think they're pretty much the same. I don't think I added a whole heap to them. Again, deposit, you're going to just deposit your tokens into the contract, transfer them in. You should already have called approved beforehand to allow this contract to spend your tokens. And then you update the balances, and yeah, that's it. And then withdraw, I don't think I added anything onto this one either. Withdraw should be more than 0. You should have the tokens deposited in order to withdraw, and then there just checks that there are enough tokens in the contract, and then again updates the balances of the message sender, and takes the amount of tokens away from them and then away from the contract. Yep, that's the two functions there. They're the same as yesterday. There's not much change in them. Pretty much what we're doing there is we're just getting the tokens into the contract and out of the contract, and then the real magic happens down here when we're using borrow and repay and liquidate. Okay, so the first two are pretty standard if you've been doing 1 and 2, so you won't spend too much time in those two. So that should be token balances, and then we have token borrowed balances. So when somebody borrows tokens, that's correct, token borrow balances, and then collateral balances. When somebody is borrowing, they actually deposit ETH and borrow tokens. So these two are used kind of in tandem. Again, total tokens in the contract. Min health factor. This will come into play later on. 1 E15 is one with 15 zeros after it. I'll talk about that later on. Again, there's our events. Our constructor, we pass in our token when we're deploying our lending contract. So we deploy our token first, and then deposit and withdraw. So the first function that we're going to look at is this borrow tokens with collateral. And as you can imagine, what this does is allows people to deposit a collateral and borrow tokens. Okay, so what you do here is you pass in an amount of tokens that you want to borrow. It's a payable function because we're going to be passing in Ether as the collateral. First thing we do is we check that the amount is greater than 0, like we do in most of our functions. And then what we're going to do here is we have uint amount ETH collateral and way. So when we send when we're sending a transaction and we send value, say for cast here for example, okay, when you send value 5 Ether there, okay, when that hits the contract, it's actually 5 with 18 zeros after it. So it doesn't come in as 5, it comes in as 5 with 18 zeros after, or 5 E18, okay. So this here is going to be 5. We think of it as 5 Ether, but it's actually in a contract sense, it's 5 with 18 zeros after it. Okay, so that's the amount in way, the smallest unit of ETH. Okay, and what we do then is from that we want to get the max token borrow amount, and what we do is we pass it over to an internal function called calculate max token borrow amount, and we pass in the amount of collateral in way, and then this function is just underneath. Calculate max token borrow amount, and what we do is we pass in again. This is way, this is whatever, say 5. If we want to deposit 5 ETH as collateral, it'll be 5 with 18 zeros after, and it returns a uint. And in here we do our calculations. Okay, what we're calculating is we're saying that the amount in ETH, so what we would call ETH, when somebody says any Ethereum they have in your wallet, we'd say 5, but really it's 5 18 zeros way. I don't mean to belabor the point, but this is for doing the maths of things here. And so what we're going to say is we need to get the collateral in way 5 with 18 zeros, and we need to divide it by 1 E18. What that does is essentially lops off 18 zeros off it, and it gives us 5. Okay, so that's how we would understand it. Then the max borrow amount is the amount in ETH, which is going to be 5 ETH. And this here, if you see what I've put here as a comment, and I've liberally sprinkled comments throughout, and I'll put this up on GitHub if anybody wants to look at it afterwards. But essentially we're saying that we value our tokens at 1,000 of an ETH. Okay, so for every ETH you can borrow 1,000 tokens. Okay, and I have a little a comment here. Ratio tokens to ETH in the real world will be dynamic. Okay, in order to calculate the amount of a token per ETH, we'd need to call an oracle. I'm not going to do that now because level 4 of the challenge out today, and it is to call Chainlink Oracle using aggregator v3 interface. So we'll do that tomorrow in the video tomorrow in video 4. But just to give us to get the contract working, we're going to say that's 1,000. So essentially what we do tomorrow is we'll call an oracle and we'll see how much we call USDT or whatever we're going to call our token is, and we'll pull it back. So tomorrow, if we were using the USDT, it'd be 2,200 or whatever ETH is today, okay? And then we return that. So again, 5 multiplied by 1,000. So somebody's deposited 5 ETH as collateral. Again, 5 E18. They can borrow 5,000 tokens, and then we return that back to our borrow tokens with collateral function, and this is going to be 5,000. And then what we need to say, or this is going to be 5,000, and so we say 5,000 here. So this needs to be less than 5,000. So we could actually borrow 4,999 there. And in the make file, we're actually borrowing, I think I have it set to 4,000. We're going to borrow 4,000 with 5 ether. So it's a well healthy ratio. Okay, so after we calculate that, we say the amount has to be less than the token borrow amount. So whatever amount we pass in, we're going to pass in 4,000, and with 5 ETH, it's going to be 5,000. So it'll pass this require statement, no problem. Then what we do is we update our ETH balances. So again, our collateral ETH balances of message.sender is going to be 5 with 18 zeros after it. Then we update the token balances. So we add 4,000 to the amount that's borrowed, and we add 4,000 into the contract, and then we transfer the token into the contract. So we've already transferred the ETH in using message.value. So that's the collateral. And we transfer the tokens out. So we call the IERC20 and we call transfer on it and send to the message.sender the amount that they requested, because it's passed here and that's acceptable. And then we emit an event. So that's our borrow tokens function. So I'm going to skip down to our repay function. So again, relatively straightforward. What we're going to do is, when we call repay, we recall the amount to repay of our own loan. Again, make sure it's greater than 0. Make sure that they have an outstanding loan, that they're not just calling it the contract for the laugh. Then we say, as with depositing tokens, the EOA should call. So again, like with anything, you need to call approval on the token before you can allow the contract to take control of the tokens, okay? So we'll do that again in our make file. It's in there. There we go. Approved tokens to lending contract from Bob, which is the account that we're going to use, okay? Then we do transfer tokens to contract. So again, on the token call transfer from message.sender to the address.this and the amount to repay. So let me see. Update balances again. Straightforward. Update balances. Take the amount off the borrowed balances because they just repaid it, and add it into the contract because it's just come back into the contract. Okay. Now we need to calculate the ETH to refund, and as I said earlier on, I was saying that this contract there was a step up, and it is because not just because of the liquidate function itself, but working with Ethereum, you don't have floating point numbers. So when we think of 5 divided by 2, the answer is 2.5. But in Solidity, there's no 2.5. It doesn't have floating point numbers, okay? What you have to do is 5 ETH is 5, again, as I said, with 18 zeros after it. And if you divide that by 2, what you get is 25 with 17 zeros after it. So that's how you have to convert. You have to convert everything up to levels of precision and back down and stuff like that to actually do it. So what we're doing here is calculate the amount of ETH to transfer back to the borrower based on the tokens repaid, okay? So what we're saying here is, if we're repaying 111 tokens, okay, what we want to do here is we want to bring it up by this order of magnitude, essentially. So we want to add 18 zeros onto it, and then when we have that done, we just divide by 1000, and that gives us 1111 E15, which is 1.111 ETH. Now I know that's a little bit confusing, but if I just if I take them down here, okay, and I say this is 5 ETH, okay, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18, okay, and then we copy this, just go in here, we do this. If that's 5 ETH, well, this is going to be 1.1 ETH, okay? And that's really what we're talking about calculating here. And to be honest with you, that's why I didn't do the contract all in one go and write it out, because I was getting confused here and I was making mistakes. And I also have something to show you with regards to the cast command, where I was making an error here. When you're using the cast command to send ether into a contract, make sure this value here, it takes in a string. 5 ether is a string. That will result in message.value being 5 with 18 zeros after it, okay? But if you do this, that will be 5 away, and it won't throw an error, and it won't tell you, and I was having issues with that. So just be careful when you're doing that. Make sure that you have your number and your denominator of ether together like that when you're doing it. It's very important. That's where I was getting a lot of issues, okay? So move back to the contract. So there we go. So that's what we're doing there. So this is a 1.111 ETH, and that's where we're saying ETH refund, okay? So they've repaid 1,111 of the tokens they borrowed, and that's how much is to be refunded, okay? And let me see now. Okay, so I'm going to move on to the... I'm going to ignore the nuke health factor for 1 second. We'll come back to that anyway, okay? But we're going to look at the liquidate function here. Okay, so as you can see, the liquidate function is larger, and I have lots of comments throughout it, and I'm going to go over it with the comments. I'm going to leave these in when I go to GitHub, and really a lot of this is, I've tidied them up a bit, but a lot of this is my kind of thought process when I was developing the contract, and I think it might help some people, because getting this straight in my own head was kind of difficult, and that's what I said about level 3 being a jump up. But I'm going to leave this in so that people can kind of see my thought processes on it, and what I'm thinking when I'm doing it, okay? And again, you can see I'm setting loads of UINTs down here. It's very gas unoptimized, but we're not looking at being gas optimized or even secure at this moment. We're looking at getting the contract working. So yeah. So let me see. So liquidate is an external function that's payable. It takes in a borrower and a token amount to repay. The reason it takes in a borrower is because it can be called by anybody, and they can send in your public address, your Ethereum public address, and they can try to liquidate you if your health factor falls below a certain level, okay? And then they can say, this is the token amount I want to repay, and based on that, they'll claim back your ETH plus a bonus, okay? So tokens currently borrowed. What it does here, what's the comment I have here? So check that the borrower has a bad loan to value ratio, i.e. the tokens borrowed exceed acceptable levels compared to ETH collateral. Have I spelled it wrong? Collateral deposited. So token borrow balances borrow will be in a standard magnitude, so it's just going to be 5,000 returned there, okay? So tokens currently borrowed, and we look for the tokens borrow balances of the borrower, and that will bring back how many they've borrowed. If they're trying to pay, this is just a require. If they're trying to pay, let me see, token amount to repay is less than or equal to, did I do that right? Token amount to repay so we're making sure that the token amount to repay is less than the tokens currently. They're not trying to pay off 10,000 tokens and there's only been 500 borrowed or something like that. If we go down here, then we're getting our ETH collateral and way. So again, up here we've transferred in when we've borrowed tokens with collateral, we transferred in way, or we transferred in ETH, I should say, in here. So ETH collateral balances, and we've gotten tokens out. So on liquidate, what we're doing here is, again, we're checking the amount of collateral that the borrower that we're hoping has a bad loan, and we want to basically steal their ETH. So we're looking to get the balance of Ethereum that they have in the contract, okay? And then what we're going to do is the borrower health factor is going to be the ETH collateral and way divided by the tokens currently borrowed. So I have a couple of them here. So ETH collateral and way, say somebody has 5,000 or 5 ETH, which would be 5 again, 5 with 18 zeros after it, and we divide it by 5,000 tokens, okay? That person would have a health factor of 1. Of 1 there, okay? So that's the same as what the health factor is going to be. It's actually, I think I have it set 1 and it's 15 zeros after, but we're going to be comparing like with like. So if the min health factor, which is 1E15, it doesn't really matter what kind of, if we have it at 18 zeros or 15 zeros or whatever way we do it, but I've just done it this way. for the time being, because it's really because I'm dividing by the tokens directly rather than cutting the tokens down to 5 or something like that, lopping off 3 and then dividing and having it down that way. So we're just gonna do it that way. I might refactor it at some stage, but essentially we're saying 5 ETH or 5 with 18 zeros after divided by 5 with 3 zeros after, which is the amount of tokens they borrowed, is a health factor of 1. So they're living dangerously there. The next one is if they have 5 ETH and they have 4,000 tokens borrowed, they have a 1.25 health factor. So nice and healthy, 25 above the min health factor. Then this one is liquidatable. If someone has deposited 5,000 or 5 Ether and they have borrowed 6,000 tokens, then that division equals 8 all the way down, which is 16.66 under the min health factor. Okay. So what we're going to do is, I think in our make file, if you look here, borrow tokens, we're borrowing 4,000 with 5 Ether. Okay, so they're 20%. So I think their health factor is like 1.2 or something like that. Okay, in that situation. But what we're going to do then is, if you look here, so what's going to happen is this health factor is going to be, in our scenario, they have this. It's going to be this. They're going to be 1.25. They're going to have this health factor here when we try to get here, and it's going to say user loan is not liquidatable. Okay, so how do we test how do we even trigger our liquidate function now that's working? So we've another function here, an external one. There's no security on it, anybody can call it, so obviously it's just for testing. Nuke health factor, pass in the borrower, and what it does is it instantly adds 987,000 tokens to the borrower balance. So that will bring their health factor. So they'll have, so instead of 4,000, they will have what, 987 or 9 whatever it is, 99 something 99 something, and that will bring their health factor right the way down, and they will then become liquidatable, because what will happen is their health factor will be something like 1.3 or whatever it is, and then it'll be much less than this one, and then we'll be able to get by it. And then what happens is tokens, transfer tokens with liquidator into the contract. So then we're winning. So once this requires hit, once we know that they have the borrow health factor is less than the minimum allowed, then we're going to say, okay, transfer the tokens into the contract from message or sender, the amount to repay, update token balance as a borrower. So again, we're saying that even though they're getting liquidated, we are repaying their loan. So it's not like they are getting some of their loan paid off. So if we were repaying 1,000 tokens and they had 5,000 out, it would bring their loan down to 4,000. They would lose some of their ETH obviously as a result, but we are paying off some of their loan. And this is how it can happen in some of them. Some of them going to do full liquidations where it just sells everything off, and then you get to keep whatever tokens or whatever loan you have. Other ones that it'll partial liquidations where it'll liquidate you down until you're healthy. We're obviously doing in our one, we can actually, it's optional. The person can just pay off your whole loan. So you can do full or you can do partial here. Calculating, so this again, we're doing calculations here. So calculate the amount of ETH to send to the liquidator, i.e. the value in ETH of the tokens they've repaid. So ignore that comment there, I can delete that afterwards. Tokens per ETH is 1,000. So again, this line is essentially our oracle for this part. We'll implement an oracle tomorrow, but we're just pretending that we're calling an oracle, and it's saying that an ETH is worth 1,000, or our tokens are one ETH is worth 1,000 of our tokens. Okay, so to get the ETH amount, you want to get the token amount to repay. So say they're repaying 5 ETH, or sorry, say they're repaying the token amount to pay 5,000. Okay. And we say divided by tokens per ETH, so 5,000 divided by 1,000 equals 5 ETH. Okay, so that's how much the liquidator is going to get, but we need to convert it to Way, because when we're transferring it back out, it needs to be in Way. Okay, so Way ETH amount, so 5 ETH, add 18 zeros onto it, so 5 multiplied by 1 with 18 zeros is 5 with 18 zeros, 5 ETH measured in Way. Now what we do is we calculate their bonus. So it's 10%, okay, in ETH that they will get for liquidating the user and maintaining the health factor of the protocol. So the bonus is going to be the ETH amount in Way divided by 10. So again, it's 5 with 18 zeros after, divided by 10, which is actually 5 with 17 zeros after. I know it's hard to read, but that's what it is. And what you'll see then is here, total ETH to the liquidators total ETH to the liquidator is going to be the ETH amount in way, which is 5 with 18 zeros, plus the bonus, which is 5 with 17 zeros. And when we add them together, so there we go. 5v18, 5v it's 5 with 17 zeros after it. So that's 5.5 ETH, which makes sense because they're trying to claiming the 5 ETH and getting 10% bonus, which is 0.5. Okay, and then payable message sender transfers their ETH plus their bonus back out to them. So what I'm going to do now is I'm going to switch over to, I'm going to save that and switch over to the make file, and we'll go up to the top, and we're going to use the make file to run through this as we go and just see the transactions happening. Okay, so I'm just going to put up J. Let me see. So the first thing we want to do is we want to make. I'll just use source env, even though it should be pulling. If when you have a make file, it's dash include.env, and it should include your env file when it's loading it. Okay. And what we do is we're going to do make deploy token. So what we're doing here is forge create in the source folder my token.sol and the contract my token private key, and we're going to use the private key, and we're calling it Alice. Actually, before we do any of this, we need to fire up Anvil. So I'll just Anvil there. There we go. And I'll just switch over to env real quick to show you what I've done here. So if you look up here again, if you can see there, the first one, the public address is 266 at the end. That's going to be, we're going to call it Bob address, and there's Bob's private key, FF80, and then the second one, 79CB. 79CB is Alice, and then this one here is going to be 69D. And 69D is Alice's private key. Okay, so we have Anvil there. I'm going to switch back over to Bash and switch back over to our make file. So we do make deploy token, and again forge create source folder my token.sol. My token is the contract, private key is Alice's PK. And just to be aware, in a make file you wrap the variable name in brackets like that. So if you were putting it a second. So if you're putting Alice PK in here, you do it like this, Alice PK. But when you're doing it in a make file, you wrap the brackets around like that. It's just whatever way the make files are. Okay, so that's fine. So we do clear. There we go. Okay, so I'm going to deploy the token. Make deploy token. There we go. And we can ignore that. I said the pure later. So the contract is deployed to 18 BC. I'll just make sure that it's correct. 18 BC. Where are we? 18 BC. Yep. So our token contract is deployed to 18 BC there. And switch back over to the make file so we can see what we're doing. Clear that. So our token is deployed. And now we're going to do deploy lending, which is make deploy lending. What we're doing here, forge create source folder token lending.sol. Token lending is the contract, private key, and it's going to be Bob's private key. Constructor args are the address of the token contract address that we just deployed. So again, token contract address is this one we just deployed, and then we're going to pass that in, and that's going to be the token that's accepted into the contract. So deploy lending. Okay, just make sure the contract address is correct. So 0AA3, 0AA3. So we have it there. So that's fine. Okay, close off our env. We don't need it. So that's both contracts deployed now. Back to clear. So we're going to move on to now is approve deposit and withdraw tokens. Okay, so first thing I'll do is make approve token to lending. So again, this is your approval, like in MetaMask when it pops up when you need to do an approval in MetaMask before you Uniswap can swap your tokens, for example. So cast send to the token contract address in this. So we're sending it to the token contract address, not the lending address. We're calling approve, and it takes an address and a uint, and we're saying we approve the lending contract address to spend 999,999 of these tokens, and it's going to be the private key of Alice PK. And the reason for that is that Alice actually has 1 million tokens here. Okay, so because we deployed it from Alice's private key, then it means message or sender 1 million tokens. So that's why Alice has the tokens here at the moment. Okay, so we'll do that, and what it means is that the lending contract will now be able to spend 999,999 of the tokens. Okay, What did I do there? Approve. Yep, I spelled it wrong. So make approve tokens plural to lending. There we go, and that's our gone through. And now we're going to do make deposit tokens. And in this case, cast send to the lending contract deposit, and it takes a uint, and we're just going to deposit 1, 2, 3, 4, 5, 6 tokens. Again, private key is going to be Alice because Alice is the person who has the tokens. There we go. And then we'll go clear. Now we'll do make check tokens deposited. And this will do a cast call to the lending contract, and it's just going to call total tokens in contract, and it returns a uint. So we'll do that. 1, 2, 3, 4, 5, 6. So that's grand. We have we know how many are there. So what I'm going to do is that was check tokens deposited. We're going to withdraw some tokens. So I'm going to do make withdraw tokens. And what this was cast send to the lending contract, withdraw, and it accepts an uint, and we're taking off 4, 5. We're taking out 4, 5, 6 tokens. Okay. So once we do this and we check it again, it should be 1, 2, 3, 0, 0, 0 when we next check again. It's Alice doing it. So she's depositing and withdrawing tokens. There we go. That's true. And we just go back here, check the tokens, and it should be 1, 2, 3, 0, 0, 0. Yeah, there we go. That's grand. So that's just the deposit and withdraw tokens. Those two functions we kind of skip by them because they weren't of major importance, but we do need some tokens in the contract, so that's why we have 123,000 in it. So we want some tokens to borrow. Okay, so that's that. So we're going to do borrow tokens with collateral. We will ask to borrow 4,000 tokens using 5 ETH as collateral. 1 ETH equals 1,000 tokens hard coded in our contract. Our L factor after this should be 0.8. No, that's incorrect. I need to change that. It should be 1.2 or something like that, I think. But ignore that for now, and I'll change it afterwards. So what we're going to do is we're going to go make, and we'll do borrow tokens with ETH. And what this is going to do is cast send to the lending contract, call the borrow tokens with collateral function, which takes a uint, and the uint is going to be 4,000, i.e. I want 4,000 tokens. It's going to be Bob this time, who's going to send it. And again, the value he's going to pass in is 5 ether. And like I said, I don't mean to be belaboring the point, but always make sure that there's no space there, that it's like that, 5 ether. Okay, that will ensure that it sends the right amount. Okay, so that's what's going to happen. There we go. Our transaction has gone through, and what we'll do now is we'll check the tokens borrowed. So make check tokens borrowed. What this will do is call cast call to the lending contract, token borrow balances, takes an address and returns a uint, and the address is just Bob's address. So there we go. So Bob has borrowed 4,000 tokens, which is fine. And now we're just going to check. We're not going to check. We're going to actually check just the contract balance. It should be just whatever Bob has paid in, 5 ether. So 1 second, just go make check ETH balance of contract. ETH balance of contract. I think that's it. There we go. And again, as I said, he paid in 5 ether, but in the contract it's 5 with 18 zeros after it. So just keep that in mind when you're trying to calculate stuff. I know we keep going on about the 18 zeros, but it's important. So let me see. So now we have the borrowed tokens. So Bob has actually borrowed 4,000 tokens, and he has deposited 5 ETH into the contract. So we'll do this now. So again, we're going to repay tokens and get back some ETH collateral. Okay. So what we'll do here is going to go make approve tokens to lending from Bob. Okay. So Bob now has we're just gonna Bob has I think 4,000 tokens, but we're gonna allow up to 999,999 again. Okay, so this is cast send to the token contract address, call approve, and it takes an address and a uint, and the address is going to say let the lending contract spend this many of the tokens. And even though we don't have that many tokens, it doesn't matter because it's just saying, we can say infinite, and then whenever you had it'll be able to spend. I'll probably keep Bob. There we go. So we clear that. Then we're going to do make repay tokens. And cast send to the lending contract, repay, and it takes a uint, and the uint is we're just going to repay 1,111, and it's from Bob. So repay tokens. Oh, make, not clear that, it's messy. Make repay tokens. There we go. It's gone through. So if we do, I think if we just check, let me see. Go back here. We should find check token borrowed. So this should be 4,000 minus 1111, whatever that is. Yeah, 2889 grand. Okay. So we're moving on to the fun part now, and the liquidate borrower. So I'm going to do, so Bob now is now standing token balance of 2889, and then he's recovered some ETH, I think, as well. So where are we here? Check ETH. Yeah, and he's also recovered some ETH based on whatever tokens he repaid. Okay, so his health factor is currently fine. What we're going to do is try to call liquidate borrower. I hope I spelled that right. What we're doing is cast send to the lending contract, liquidate address, takes in an address in the UINT, and we're saying we want to liquidate Bob, and we're going to pay back this much of his loan, 1655. Okay, and it's Alice that's doing it. Okay, so let's see what happens. User loan is not liquidatable. So as we said down here, let's minimize that for a second. As we said down here, user loan is not liquidatable because the borrower health factor is actually higher than the min health factor. So what we're going to do then is we'll click back over, and I'm going to clear this, and I'll actually just run that again so you can see liquidate borrower. So here we go. So user loan is not liquidatable. So what we're going to do now is we're going to do nuke health factor, and all this does is cast send to the lending contract, calls nuke health factor with the address of Bob, and from use analysis private key. And again, as we said here, it just adds a ton of tokens onto the borrowed amount, and then that will ensure that this require statement gets passed, because he'll now have a much his borrower health factor will be well under 1 now. Okay, and it's set at 1, and it'll be as I said, it's called nuke health factor. So that's what it does. It nukes the health factor. There we go. And now if we do liquidate borrower, I should say. There we go. So we have now done that. Click back over. I think that's the last thing I have in the make file. But we will be able to see if we went back and we said, let me see, just to see what we do. Check tokens borrowed. So I think he had 2889 and we repaid 1655. So I can't do the maths exactly, but it should be, what should that be? So there should be 1 2 something. Is that right? Is that correct? Oh, sorry. Yes, you can't do the maths because 1 2 3. It's actually 1 2 3 4, and we had. Remember, we in nuke health factor we added on 987 tokens to the here. So you have to take it's 988234, and if you take the tokens that we did this to reduce his health factor, we'll leave you with 1 2 3 4. So that's how much is left in the contract now. And also I think we can just check ETH really quickly and check ETH balance of contracts. There we go. Again, it was 3 something the last time. It's down to this, and it's because we've repaid I think it removed 1.65 plus your bonus collateral, which will be 0.16 or something like that. So that's it. As you can see, all the functions are working, and we're going to move on to doing the Oracle tomorrow, and I hope that helped.